In this video, you are going to learn the following: the definition of velocity, instantaneous velocity, average velocity, the magnitude and the direction of velocity, and finally, how the velocity is related to speed. Let us consider an object in a one-dimensional motion. I take two positions of the object. The first position is called the initial position, and the second position is called the final position of the object. Now, let us put the x-axis on the path. It doesn't matter where you put the axis. The initial position can be 0, or some other number. Positions have unit. It can be meter, kilometer, or mile. The SI unit of position is meter. Here I take the unit as meter. Let the initial position be x1, and the final position x2. So x1 is 2 meters, and x2 is 6 meters. Let t1 be the time when the object is at the initial position, and t2 be the time when the object is at the final position. The final position minus the initial position is the change in position of the object, that we write as delta x. The change in position is also called the displacement of the object. The final time minus the initial time is the change in time, which is written as delta t. Delta t is the time interval, which is the time the object takes to go from x1 to x2. Now, divide the displacement by the time interval. This ratio is called the velocity of the object between the times t1 and t2. So, velocity is change in position over the time interval or displacement over the time interval. We are dividing by time. So velocity is a rate, the rate of change of position. Note that this velocity is the velocity of the object over a time period between the times t1 and t2. Now, if you want to find the velocity at an instant of time or a moment of time, you need to take t2 is equal to t1. Then we will have only one time, which is t1. And the velocity at t1 is called instantaneous velocity. But if t2 is equal to t1, then delta t is 0, and delta x is 0. And the velocity will be 0 divided by 0, which is undefined. So, you cannot take t2 as equal to t1. Then, how to find the velocity at t1? The workaround is, instead of taking t2 as equal to t1, take t2 as close to t1. That is, take delta t close to 0 but not 0. For example, you can take delta t is 0.001 second. Then find the displacement of the object over the short time interval, and divide that by the time interval. You will get the velocity at t1. This velocity is the instantaneous velocity at time t1. If you are familiar with calculus, this instantaneous velocity is nothing but the derivative, dx over dt. Don't worry about this if you don't know calculus. Now we have two velocities, the instantaneous velocity, which is measured over a short time interval, and the velocity, which is measured over a long time interval. We call this velocity the average velocity because during this time interval, the object can have different instantaneous velocities at different times. And this one velocity that we get is the average of all those velocities. We put a bar over the letter v to represent the average velocity. For instantaneous velocity, we just use the letter v. Further, if you just say velocity, which means instantaneous velocity, you see that the position of the object changes from here to here. If you take this side as east, this will be the west. Then, the displacement of the object is in the eastward direction. Since velocity is displacement over time, the direction of velocity is the direction of displacement. So the direction of velocity is eastward. So velocity has a direction. Any quantity that has a direction is called a vector, so velocity is a vector. Velocity can be positive or negative. The absolute value of velocity is called the magnitude of velocity. So, magnitude is a positive number. Also, if the velocity is instantaneous, then the magnitude of velocity is just the speed of the object. So, velocity of an object is nothing but the speed of the object with direction.